HTTP streaming. In HTTP streaming, the video is simply stored in an HTTP server as an ordinary file with a specific URL. When a user wants to see the video, the client establishes a TCP connection with the server where the video file is stored and issues an HTTP GET request for that URL. Then the server sends the video file within an HTTP response message as quickly as possible. That is, as quickly as TCP congestion control and flow control will allow. On the client side, the bytes are collected in a client application buffer. Once the number of bytes in this buffer exceeds a predetermined threshold, the client application begins playback. Specifically, it periodically grabs video frames from the client application buffer, decompresses the frames, and displays them on the user's screen. The use of HTTP over TCP also allows the video to traverse firewalls and NATs more easily, which are often configured to block most UDP traffic but to allow most HTTP traffic. Streaming over HTTP also obviates the need for a media control server such as an RTSP server, reducing the cost of a large-scale deployment over the internet. Due to all of these advantages, most video streaming applications today, including YouTube and Netflix, use HTTP streaming over TCP as its underlying streaming protocol. Next, free fetching video. Now to understand this free fetching, let's consider an example. Suppose the video consumption rate is 1 Mbps, but the network is capable of delivering the video from the server to client at a constant rate of 1.5 Mbps. Consumption rate is 1 Mbps. Then the client will not only be able to play out the video with a very small playout delay, but will also be able to increase the amount of buffered video data by 500 kilobits every second. In this manner, if in the future the client receives data at a rate of less than 1 Mbps for a brief period of time, the client will be able to continue to provide continuous playback due to the reserve in its buffer. And this prefetched video is naturally stored in the client application buffer. Such prefetching occurs naturally with TCP streaming, since TCP's congestion avoidance mechanism will attempt to use all of the available bandwidth between server and client. In the next video, I am going to discuss about the interaction between client and server for HTTP streaming. Thank you.